I try to imagine a fellow smarter than myself, and then I try to think, what would he do?
Charge up your axons, ready your receptors, and shift your lobes into upper beta phase. You are listening to Smart Drug Smarts, the podcast dedicated to helping you optimize your brain with the latest breakthroughs in neuroscience, nootropics, and psychopharmacology.
Hello and welcome to Smart Drug Smarts. I am your host, Jesse Lawler, excited to bring you the 52nd episode in this podcast dedicated to the improvement of your own brain by any and all means at your disposal. We're going to be talking this week about something called CRON. That's an acronym for Caloric Restriction with Optimal Nutrition, and kind of vectoring off that's something that you might have heard of. It's a dietary thing. We'll get into what that is, but a way of tricking your body into thinking that you're participating in CRON without the hassle of actually doing so, with a substance known as oxaloacetate. And we're going to be talking with Alan Cash, who is a physicist and entrepreneur who certainly didn't invent oxaloacetate because it's a part of pretty much all living systems. But for the last few years, he's been a popularizer of it and has a company based around that. And he's going to be telling us why oxaloacetate is something that we may want to be aware of. We're also going to be talking a lot about everything from monkeys to flatworms to mice, a lot of animals in this interview. And then in the Ruthless Listener Retention Gimmick, we're going to be talking about both ghosts and robots. So we got animals, ghosts, robots, a little bit of everything in this one. It's a longer than normal episode, so buckle up and let's go into This Week in Neuroscience.
Smart Drug Smarts, This Week in Neuroscience.
So research from about a week ago out of the University of Copenhagen, the Faculty of Health and Medical Sciences, says high-fat diet postpones brain aging in mice. This, of course, off the cuff sounds really awesome because who doesn't want to postpone brain aging, whether or not you're a mouse? On a deeper look, it's not quite as rose-colored as that. These are not healthy, normal mice. These are mice that have the mouse equivalent of something that in humans is called Cockayne syndrome, which is, if you've ever seen these little kids that 7 years old and have the appearance of like a hyper-aged 70-year-old man, and they're basically aging at this phenomenal rate, and unfortunately these children typically die at 10 to 12 years old of what, for lack of a better term, is old age. What's going on in that particular syndrome is that the repair mechanisms in the cells are turned on to warp drive at all times. So normally, as you might expect, cells fix damage within themselves, but they fix damage on an as and when needed basis. And when everything is hunky-dory, they don't do that. But in children with Cockayne syndrome, the repair mechanisms are constantly turned on, and thus the biochemical resources needed for those repairs run out really quickly. Then when actual cellular damage does happen, when something is needed to be repaired, there's not the raw materials to do it anymore. So what these researchers are suspecting is essentially sort of a lack of biochemical resources within the cells that's the limiting factor here on the cellular survival within these children with Cockayne syndrome. So they have mouse equivalents for this, as they do with many things. And what they found in this study is that placing mice on a very high-fat diet seems to stave off cellular aging. Now, we've talked about before, there's two ways that energy is transmitted to cells in your body. One is by glucose, and glucose is sort of the first order energy system, the body's first line of defense for running out of energy. And then after that, if we're out of glucose in our bloodstream, then the body goes to our reserve tanks, which is fat, breaks those down in something called ketone bodies. We talked about this on the ketosis episode, so ketosis, and those ketone bodies are used as reserve fuel. Now, apparently, providing these mice with lots of excess fat in their diet kept them sort of stocked up on all the ketone bodies they needed, so even though their cells are in this constant repair state, they didn't run out of what they needed in order to do those repairs, and they were able to stave off the visible, physical, experiential effects that go along with this hyper-accelerated aging. Said postdoc Morten Scheibe-Knudsen from the National Institute of Health. In cells from children with Cockayne syndrome, we have previously demonstrated that aging is a result of the cell repair mechanism being constantly active. We therefore hope that with a diet high in coconut oil or similar fats, there will be a beneficial effect because the brain cells are given extra fuel and thus the strength to repair that damage. So I'd say the study for those of us that have normal metabolisms is a little less exciting than the headline would make one believe, but nevertheless some very promising research for people that are afflicted with Cockayne's or similar syndromes.
Smart Drug Smarts.
And I would also like to throw a little thank you out there to all the people that have been emailing who are on the email alert list for the podcast. And, Rhiannon has been writing up a per episode email, just, hey, the episode's out. A little bit of a teaser for people, maybe if you missed it in your podcast feed or whatever. And we've gotten a lot of people writing back responses, sometimes quite lengthy and very illuminating to those emails. And it's a pleasure to receive those. So thank you so much for everybody that's been writing in. And yeah, if you're not on the email list, definitely do consider consider signing up for that. It's over there in the sidebar at www.smartdrugsmarts.com. Signing up for the email list will entitle you to things like emails. We need a better free giveaway. But for right now, for this week, that's all I've got to offer. But we'll dangle some more attractive carrot in the future here. But anyway, just really appreciate the feedback that we've been getting, including from those of you who are giving us notes on the iPhone and iPad app Axon that we've got out now. A lot of the downloader and listener feedback that we've gotten on that app is being incorporated right now. We've got, I think it's a version 1.2.3 that's in the store right now. 1.3 is going to have a ton of new features, and we're trying to get that one all hunky-dory before we put it out there, but there might be a couple of incremental releases looming somewhere on the not terribly distant horizon.
Smart Drug Smarts.
So as I said earlier, our guest today is Alan Cash. Alan has a product called benaGene. His company is called Terra Biological LLC. He's based out of San Diego, California. And he was a speaker recently at the Bulletproof Conference, which a friend of mine attended and said he was a really engaging speaker, had an interesting story to tell, and would be somebody great to get on the show here. We're going to be talking about how Alan got interested in life extension, caloric restriction, and its effects on the animal kingdom, and finally how that led him down the rabbit hole that wound up at oxaloacetate, which is the star ingredient of his benaGene product. With no further ado, here's our talk.
Most of medical science, as we understand it, is not treating the cause, it's treating the symptoms. You know, you've got a cold, your nose is running. Okay, let's give you things that stop your nose from running instead of, hey, let's kill the virus. The problem was that as we get older, things like this happen. My background is not in biology. I'm a physicist. And as a physicist, we tend to take a lot of data and look at it and try to find simple things like F equals MA or E equals MC squared. We tried to distill all this information into something unique and simple and fundamental. And when I looked at aging with this mindset, what I saw is that almost nothing works except calorie restriction. They've been doing it since the 1930s. It's when they take animals and they determine a baseline, and then they feed them 25% less than what they normally eat in that baseline. And the animals, surprisingly, even though they're getting less energy, they live longer. They live about 25 to 50% longer. And it's not restricted to one type of animal. I mean, they've tried this in yeast and in spiders and in guppies and in rats and mice and dogs and monkeys. And they've even done clinical trials in people. And what they keep seeing is that this is incredibly healthy for you. And there are some cultures that practice fasting on a regular basis, and probably because they've seen some major improvements in health. So, you know, the scientist in me, I'm going to try this. So I tried it for 30 days. I restricted my diet down by about 25%. You can go a little bit more than that. Obviously, if you go too far, you starve to death, but that's down around 45, 50% restricted. So 25% is pretty mild.
So how many calories a day does that wind up being for, let's say, like me, for example, I'm about a 180-pound guy. So what would I be taking my daily caloric intake down to?
It's about 1,500 calories.
Wow, yeah, it's not a lot.
You know, compare that to like my daughter who plays high-level volleyball. She probably burns through 6,000 calories a day. It's quite an adjustment. I did it for 30 days, and my wife suggested that I was irritable. She was pretty happy when I gave up that idea. You know, there are people who do it most of their lives, and they're incredibly healthy. I mean, in clinical trial, when we calorie restrict humans, we see a virtual elimination of high blood pressure. Atherosclerosis seems to go away. Diabetes drops out. Even in primates, calorie restriction eliminates type 2 diabetes. So I started looking for what is the cause of calorie restriction.
One thing that I wonder is, what is the level of energy that a person actually feels? I mean, you might live a heck of a lot longer, but on the other hand, are you going to be sluggish and lethargic throughout all the days of your extremely long life?
That's a great thought experiment. And you would think, God, you restricted energy, they've got to be tired all the time. But when you calorie restrict animals, you can always tell which group it is when you walk into the lab, because they're climbing the cages. They're looking all over the place for food. I saw it in myself. I restricted food, and I was like, hey, let's go do something.
That's exactly the opposite of what I thought you were going to say. That's really interesting, but it makes sense.
It is contradictory to the thought experiment, but I guess that's why we do experiments, is because sometimes we see things that we don't expect. But there are some downsides to calorie restriction. And again, it goes back to, what is the cause of calorie restriction? What is the molecular mechanisms that are being turned on in the body that cause you to live longer? And there's been a lot of work, since the 1930s in calorie restriction, but it's only in the last, 15 to 20 years that we could look at, for instance, gene chips, where we could look at 20 to 25,000 genes all at the same time and see what happened. And so that's one of the things we did is we looked at the difference in calorie-restricted animals and in normal control animals. And it turns out about 10% of their genes change in expression significantly. And you think about that, that's a lot, just by eating less. Mm-hmm. Your DNA doesn't change. It basically stays the same throughout your life, other than, random breakages and mutations and whatnot. But pretty much your DNA stays the same, but your genes turn on and off all the time. So there are programs in our bodies that are changing these genes all the time. And it turns out one of the biggest ways to change your DNA expression is to eat differently. So if you go out and supersize everything and get all your McDonald's French fries and eat, a super high fat diet, high calorie diet, your body will actually produce proteins to help you break down those fats and to use those as energy. If you go the opposite way and say, well, I'm not going to eat as much and I'm going to restrict down my carbohydrates so I'm not just pumping myself with glucose, your body does the same thing, but with different genes that are turning on and off. And it turns out in calorie restriction, the genes that are turned on are things that rebuild our cells. They clean up our cells. It's called autophagy. And they also create more mitochondria in the cells so that if you do get some food, you can process it much more effectively. So I started following the energy pathways of calorie restriction. How do we produce glucose? And what I saw is this one compound called oxaloacetate. It's part of the Krebs cycle. It's one of those metabolites that you don't hear about it a lot. It doesn't come up at dinner parties very often.
Can you give a quick elevator version of the Krebs cycle for people that aren't familiar with that?
Yeah. In your cell, there are these little things that look like ellipses or jelly beans. And they're called mitochondria. And they produce most of the energy that allows your cell to function. They burn glucose, and they do it very efficiently. They're really cool little things. And within the mitochondria, there's what we call the Krebs cycle. And we call it that because this guy named Krebs back in the 60s, was a biochemist genius. He figured out the step-by-step process of how glucose breaks down in these mitochondria and provides your cell with energy. And it has some compounds that you've probably heard of, like citrate. which is a relative
Smart Drug
of
Smarts,
vitamin
where we
C.
turn information
But
into
all
sound,
these
into bits, into packet
little
data that turns back into
compounds,
bits and sound,
the
and then into
Krebs
neurotransmitters that release funds that release
metabolites
mail order synthetic
are
chemicals that
together
cross the blood-brain
and
barrier to
together
release
they
augmented
provide us
performance
with
from your
energy.
brain.
So we were looking at one of those particular metabolites. So I went and found my friend at UCSD, who is a very, very smart biologist. And I don't doubt that someday he'll win the Nobel Prize. He's just brilliant. And I explained to him what I was trying to do, how we've seen in yeast this increase in lifespan with an increase in the NAD to NADH ratio, and how calorie restriction, seems to be working along these lines. And I wanted to do the same thing and see if it could mimic calorie restriction without having to eat a lot less, because I really like ice cream. So we started with worms, and I put oxaloacetate into the agar of these worms and just let them live and counted them. They were either alive or they were dead. You poked them with a little needle, and if they didn't move, that was a dead one. Just did counts after counts after counts. They're microscopic. I mean, you can just barely see them with the eyes. So I spent hours and hours and hours looking through a microscope, counting worms. My wife thought I had gone crazy. But the worms lived 25 to 50% longer. We then tried it in flies, and the flies lived 25% longer. And then we tried it in mice. And I didn't want to wait 3 years to see if this was working. So Steve Spindler at UC Riverside came up with just a brilliant idea of screening for calorie restriction mimetics, looking at gene response. So I thought, well, we could raise a control group that ate what they wanted. We could raise a calorie-restricted control group, and then we could raise a group on oxaloacetate and, give them as much as they wanted to eat. And then in about 3 months, we could take some of their tissue and look and see how the genes are responding. And when we did that, we had a 99% correlation with calorie restriction and oxaloacetate. I mean, they were almost identical.
Should there have been in that study like a fourth group that was both calorie restricted and getting oxaloacetate supplementation?
You are right. And there should have been, because what if you could do both and live 100% longer? I mean, what the heck? But no, we didn't do it. You got to remember, too, that this was all being done from the Bank of Allen, which not the biggest bank in the world, but it was interesting to me, so I underwrote all these tests. We were fortunate in that I had raised enough mice that I could let some of the ones with the oxaloacetate live out their lifespan. So during the next 2 years, 3 years, I just continued to feed them with the oxaloacetate, and I had a control group, and I compared who's going to live, who's going to die, and kept track. And as it turned out, the oxaloacetate mice lived longer. So I started looking through the literature, and they had done a clinical trial with oxaloacetate in humans. So here was our test compound, and they've already tested in human beings. And what they found is that there were no side effects. The tests were done in diabetics. Calorie restriction eliminates type 2 diabetes. And the addition of oxaloacetate to these diabetics reduced fasting glucose levels by 25% in 45 days with no side effects. And I thought to myself, wow, that's, first we're getting the lifespan effect. Now we're getting the anti-diabetic effect. And my gosh, where's the follow-on study? So I'm looking through the literature. There's got to be something on this, because, here's a treatment for diabetes, the scourge of modern man right now, and there's no follow-up. I can't find a thing. So I hop on a plane. I go to Japan. This is up by a place called Fukushima, which which will become famous later on. And it's at the University of Sendai, Tohoku University. And I go to the department where this was written. And unfortunately, the author of the study had passed away. But they knew of the study. I said, are you familiar with this? And fortunately, they spoke English because their English was a lot better than my Japanese. And they looked at it and said, yeah, we're familiar with this. And I said, yeah, you reduced fasting glucose levels in diabetics by 25%. And they said, yeah, that was pretty amazing. And I said, yeah, and you did it with a natural compound. And they said, yeah, we did. And I said, where's the follow-on work?
They've got a lot less diabetes in Japan than in America, so maybe it was less of a wow factor for them.
Well, what they said to me is, yeah, it's a natural compound, no patents. And that was pretty much the end of our discussion. You can't blame them because when the average cost of bringing something to the market is $800 million, at least in today's money, and you can't protect it with intellectual property, who's going to spend that kind of money?
Well, yeah, but if it's naturally occurring compound, you don't have to spend that money, right?
Well, actually you do, because in the United States, nutritional supplements cannot prevent, treat, cure, diagnose any disease.
Oh, right. The fine print that's on all the vitamin bottles you buy.
Yeah, you can't do it. So even if it works, you can't talk about it. We made a very big point when we decided to become entrepreneurs and go into the marketplace and make a nutritional supplement. We had to not talk about diabetes because it's a disease. So we talked about anti-aging. And we put this out on the marketplace. It turns out we were able to get into Canada first in 2007. And in the United States, the FDA wanted us to have this as a new dietary ingredient. And I said, no, wait a second. Oxaloacetate is in every food you eat. It's in chicken. It's in peas, it's in potatoes, it's in apples, it's in spinach. And they said, well, yes, but nobody has been selling food specifically for its oxaloacetate content. So it's got to be a new dietary ingredient. So I spent about $1 million of the Bank of Allen, and we did toxicity studies and found that this stuff is, not surprisingly, it's about as toxic as vitamin C. So you can take an awful lot of it. And we presented this to the FDA, and they said, well, we'd like to see more studies. And it's like, why? I mean, this is a human metabolite. I mean, it's related to vitamin C. It's about as toxic as vitamin C. We tried to kill the mice. We gave them 5,000 milligrams per kilogram of body weight. I mean, none of the mice died. None of the mice even got sick. And they were like, yeah, but this is a new dietary ingredient. I think that FDA works on a basis of fear. They are afraid of making a mistake that will hurt people. And because I wasn't a major pharmaceutical company, because I only spent $1 million on it instead of 10 million or 100 million, they were afraid. And we duked it out. I said, I am following the law. I want enforcement to weigh in on this. And so they said, fine, we'll call enforcement on you. I said, fine. We were yelling back and forth. This is not generally the best way to deal with a regulatory agency. And they called me up the next day, and there were two of them on the phone. I guess they needed to have witnesses. And they said, well, you're right. You followed all the regulations, and this is legal to sell in the United States. I said, okay, we're going to go do that. Would you send me a letter? No, we're not going to send you a letter. I said, what do you mean? They said, we're not going to send you a letter. So I had to send them a letter, certified mail, basically stating all the things that had led up to this conversation and what happened, and sent it to them. And then I waited 6 months, and then we introduced it into the United States, and that was back in 2009. and I haven't heard from them since. Now, that doesn't mean they won't be at my door tomorrow, but so far we've been allowed to sell this in the U.S., and we've really had very limited complaints. We've had 2 reported adverse effects. They were both headaches. We're not 100% sure it was due to the oxaloacetate. But that's pretty low for any kind of supplement when you consider how broad the population is and how diverse the population is.
What are the amounts of oxaloacetate that are in the supplement versus how much one would normally get in their diet?
Yeah, that's a great question. The FDA asked me that exact same question. And so we had to do a lot of research. And it turns out some foods have a lot of oxaloacetate and some foods have very little. But for the most part, for the average diet, our supplement gives you about 100 times the amount of oxaloacetate that you'd get in your daily diet. And the foods that have the most oxaloacetate in them are foods that are very high in mitochondria. So like pigeon breast, squab has very high amounts. But even with squab, you have to eat like 30 pigeon breasts in order to get as much oxaloacetate as in one capsule of our supplement.
So at 100 times the amount that a person's normally getting in their diet, is that amount so high because most of it is not making it through your digestive tract and actually into your bloodstream? Is it something that's maybe largely broken down in the digestive process? Or why such a large ratio?
Well, it turns out we have some pKa data on that. And as it turns out, oxaloacetate is water soluble. And as such, it goes into the cells so very quickly. As a matter of fact, we tried to make a time-release version of it. We were shooting to slow down the absorption by the body over an 8-hour period, to about 40 minutes. It's one of those molecules that the body just goes, ooh, I like this, and just pulls it in. So absorption's about 100%. And the reason it's so high, 100 times, and these pills that are in our supplement are tiny, is because of all the Krebs cycle metabolites. Oxaloacetate is the one that is in very, very, very small amounts in your body. And we believe that it may be a signaling molecule. For instance, you need oxaloacetate in order to break down the triglycerides into the energy components. Oxaloacetate's right at the crossroads there. So it does a lot of different things in the body, but its availability is very, very small. So with just small amounts that we're giving, 100 milligrams, that's nothing. It seems to do a lot. Now, how do we know what to give people? Well, what we did is we went back to that clinical trial, and they had given people anywhere from 100 milligrams a day on up to 1,000 milligrams a day. And there weren't any problems either at the 100 or at the 1,000. It all seemed to work. So what we thought is if we're taking this as an anti-aging compound, we want to take the smallest amount that has proven benefit. And if we're seeing a drop in fasting glucose levels in humans, that's exactly what we would expect to see with calorie restriction. And so where to start? At the lowest dose, proven to show an effect in humans, which was 100 milligrams.
I'd like to hear about how this affects hippocampal neurogenesis.
Well, we had a weird thing happen. One of the benefits of getting a new compound out there into the marketplace is you get feedback. And we were getting feedback from all sorts of people, and all of a sudden, I get this large order, and I'm like, that's odd. It was from Kansas. And so I called up the person. I said, why are you ordering so much of this compound? And they said, well, I'm a university professor. I said, oh, okay, you're going to study it. That's great. Hey, I'll give it to you for free. I'll underwrite that research. What the heck? And they said, no, it's for me. And I'm like, well, okay, what's up there? And they said, well, I have Parkinson's disease. And I'm like, yeah, so? And they said, well, my neurologist recommended that I take this. I said, well, what were the effects? And she said, well, I was in a wheelchair. I couldn't stand for more than 2.3 seconds. I couldn't comb my hair. I had trouble buttoning, buttons. But the thing that bothers me the most is I can't type because I can't type up my research. And I said, well, is it helping at all? And she goes, yeah, it's helping a lot. I said, well, let me send you a survey and you can try to define how much it's helped you. There are these surveys you can take. It's called a PDQ-39 form, which looks at Parkinson's disease quality of life. And there are 39 questions. It's things like, can you tie your shoes? How do you feel today? And it gives a scale of 0 to 5. And it's been shown to be statistically significant as far as defining how you're doing in Parkinson's disease. So I said, try to do one that was before and then give me one that's now. And so she did that and sent it back. And I called her back and I said, you've had a 90% remission in Parkinson's disease. I said, I've looked through the literature. That doesn't happen. And she said, yeah, and not only that, I've cut my dopamine dose in half. What was interesting, though, is she was a professor of pharmacology. And so based on that, the University of Kansas said, we're going to do a clinical trial. So they put oxaloacetate in clinical trial for Parkinson's disease, and it was a 2-year trial. It's just finishing up now. It's double-blinded, placebo-controlled, so I have no idea if it worked or not. We had some very smart people like Russell Swerdlow over at UKansas, who is like Mr. Mitochondria. The guy's just brilliant. And he started looking at the oxaloacetate and what it does to the brain. And what he saw, and this was just published in the journal Human Molecular Genetics, which is an Oxford journal. Well, I'll just read you the title of the article. This was published in July 2014, so this is pretty new information. Oxaloacetate activates brain mitochondrial biogenesis, enhances the insulin pathway, reduces inflammation, and stimulates neurogenesis.
Them's fighting words.
And what's interesting is this ties in very much with another study that we did that was done at the Pennington Institute, which is in Louisiana. And this was done under a 2-year grant from the Alzheimer's Association. And we took mice, what we call Alzheimer model mice. So these mice get a lot of tangles in their brain very early on, and you can see the effect of that when they are put in a water maze, because mice don't like to be in the water, so they run around until they can try to get to a platform that gets them out of the water. It's not waterboarding, it's water mazing. It's a lot nicer. What we saw in that is that the mice that were fed oxaloacetate had a 50% increase in short-term memory and a corresponding decrease in hippocampal plaque density in the brain. So we thought that was pretty impressive.
Well, any final thoughts you'd like to leave people with?
Yeah, I would like to talk about a new product we have on the marketplace. The FDA has given us an orphan drug designation for brain cancer, because when we add oxaloacetate to the standard chemotherapy, it increases survival by 237%. And in 30% of those animals that was done in that test, we couldn't find the cancer afterwards. This is human glioblastoma tissue that's implanted into animals. And so FDA thought that was pretty amazing and gave us an orphan drug designation. That doesn't mean this is a drug. It's a medical food. It's called Cronaxal, and that's www.cronaxal.com. And so if you know of someone with a brain tumor, you may want to just let them know about this, because in our first 17 people that we have MRI data on, we were able to stop the growth of these very aggressive tumors in 88% of them.
Smart Drug Smarts.
So thank you so very much to Alan Cash for sharing his time and insight with us. I realized, so this is like 24 hours after I did this interview. Stupidly, there's a really important question that you probably noticed that I forgot to ask in the interview. I'm sending Alan an email to try to get the answer to this one, although obviously I won't have this until next week's episode. But I can only assume that Alan has been taking his own product for at least the past 5, 6, 7 years. And I'm sure all of you are also curious how this has affected his own blood work. Is he sporting the blood chemistry of somebody who has been on the caloric restriction with optimal nutrition diet, despite maintaining a ice cream friendly diet, I guess? Anyway, we'll get that answer from Alan, and I'll let you know on the next episode. But now, the moment you've all been waiting for, the Ruthless Listener Retention Gimmick.
Smart Drug Smarts. Ruthless Listener Retention Gimmick.
So as promised, this Ruthless Listener Retention Gimmick is going to deal with both ghosts and robots. Real robots, fake ghosts. It's kind of like this would be an optical illusion, except the optics aren't really the main part of it. It's more like a tactile illusion. But scientists in Switzerland, at the Federal Polytechnic School in Lausanne, Switzerland, recently published a study in the journal Current Biology about a robotic arm that is synced to, but not perfectly synced with, a hand control that subjects can use that basically allows them to touch their own back. They're operating a robotic hand control in front of them that then powers or directs the action of a robotic hand behind them so they can touch their own back. So you're moving your hand in front of you and making something touch you on your back. And that's a little bit weird, but when they have the robotic arm timed so it's perfectly in sync with the motions that you're making in front of you, your brain very quickly recognizes, okay, that's me touching myself. There's a perfect mapping. But what they did is then they started messing with the time delay between when a movement on the sensor in front translated to a movement in the robotic arm touching the person's back behind them. And after a certain amount of latency, after a certain amount of time delay between the directing motions and the resulting motions, a very spooky thing started to happen with almost all volunteers who participated in this experiment. They really got the sense that there was somebody else touching them, that it was a ghostly presence that was touching them and not just a mechanistic behavior of them touching themselves. Apparently, this is very, very, very spooky, and scientists think that this can shed a lot of light on something that's been reported forever, and oftentimes in very extreme situations where people are lost in the wilderness or in real life or death instances. This is sometimes called the third man syndrome. In fact, there's a book called The Third Man Syndrome, which describes this, but the sense that a ghostly presence, sometimes it can be thought of as a malevolent presence, and other times as more of a guardian angel or a spiritual protector, is present with someone at a time that there really is nobody there, and sometimes there could be nobody there. But now, for the first time using pure mechanical trickery, scientists have been able to consistently replicate this strange feeling in regular healthy volunteers in a lab environment. Cool stuff.
Smart Drug Smarts. The podcast so smart, we have smart in our title. Twice.
Okay, that is the entire episode, number 52. Shutting it down. If you liked what you heard, please recommend this podcast to your friends, your enemies, passersby who you meet on the street who you notice have ears and or a brain. And then once you've done all that, if you're feeling super generous and you wanted to leave us a review on iTunes, that too would be totally helpful as far as helping to get the word out to all the other people in the world that could be listening to Smart Drug Smarts, but think that they have something better to do. The show notes for this episode will be online at www.smartdrugsmarts.com, including the links to everything that we talked about here. I'll be back at you next week, same time, same podcast, and with the same unflagging commitment to helping you fine-tune the performance of your own brain. Have a great week, and stay smart.
You've been listening to the Smart Drug Smarts podcast. Visit us online at www.smartdrugsmarts.com and subscribe to our mailing list to keep your neurons buzzing with the latest in brain optimization. Smart Drug Smarts should be listened to for entertainment purposes only, although some guests on the show are medical doctors, most are not, and the host is just some random guy. Nothing you hear on this podcast or read at smartdrugsmarts.com should be considered medical advice. Consult your doctor and use some damn common sense before doing anything you think might have a lasting impact on your brain.